Hello guys, and welcome again to another video. Right? Today we shall be considering the physics alternative to practical GC. And to understand this, you need to understand some instructions and information about these exams. Now, about physics alternative to practical, the truth is that you are not going to be performing any set of practicals. You are going to be given the instructions and you are going to plot a graph. So I think more like a kind of examination where practical is not going to be done, but you are going to see the diagram and the explanation on how the practical should have been carried out. Now, there are a lot of things the examiner, the chief examiner, want to test you about. You must be very careful in taking readings and you must strictly adhere to the instructions and information of the examination. So to begin with, the instructions is given below. I will try as much as possible to demystify my explanation and make sure you do get it very well. And I urge you to subscribe to this channel if you are a newcomer and also click on the notification button. So let us look into the first question. I'm only going to be doing one question because of time, but I can tell you if you follow the instructions for this one, the other stuff, I mean question 2 or 3, you are only answering 2 out of 3 questions. So this is number 1. Question 2 or 3, we also follow the same path. So let's see. This says the diagram above, this diagram is an experiment that is performed, but you are not performing any of these experiments. This diagram above illustrates a metal rule. You can see this is a metal rule whose center of gravity G, this G, is suspended. There's a metal rule whose center of gravity is suspended from a rigid pointer P. You can see point P up there. So that's that. Now, in continuation to that, the distance, trying to adjust my writing stuff here is lagging. Okay, fine. The distance X, this is the distance X, between G and P is measured and recorded. So distance between this point P and this point G, the gravity center, is measured and recorded. The metal rule is slightly displaced sideways, that means it's bent and stuff like that. You are not doing anything so that it performs simple oscillation. Do you understand? It's like a pendulum ball. You know the type of oscillation you see in this type of experiment. Basically, you call it a to and fro motion, simple harmonic motion. So now the question we have here is that the time t for 20 complete. So the first instruction I can keep in my mind is that there are 20 complete oscillations. I think that is too thick. But now this notwithstanding, I think we have what we want. So there are 20 complete oscillations. So we have to keep that at the back of our 20 complete oscillation. So we're still trying to adjust this stuff. I'm just going to leave it to work. I'm not going to give me stress. So 20 complete oscillations are there. And the period, capital T, of the oscillations are determined and recorded. Now, the procedure is repeated for 4 other values of X. Yes. Now, figure 1A, which is this guy, 1A right here, and figure 1B, which is this guy, on page 3, here is on page 1, illustrates the distances xi and their corresponding times ti, where i's are 1, 2, 5. 1, 2, 3, 4, and 5 means 1, 2, 5. But to measure and record x1. So now the first thing you need to keep in the back of your mind is that when you are performing experiment, as you are reading the instruction, do follow what you are asked to do. So I am actually asked to do a kind of taking I and looking for xi and ti. So the first thing, I'll be doing that at the other page. This thing is still very much not conforming with the way I want it to conform. It's doing me that, and I still have a long way to go. So now, here, looking at this now, I have a table before me now. So I'm going to start that table with what I call the serial number. I'll write that one as S/N. It's going to give me issue. So this is not the way I want it to be. Maybe I'm going to remove the charger, I guess. That's the issue. So I have the serial number. Hopefully it will work now. So the serial number is given in terms of I have 1 to 5. So I'm going to label these as I said I. This is lagging. Seriously lagging. So let's just that so that we can have the readings. And I don't want it to be I will not write anything. So put down like this was still used yesterday, like I said. Now fine. So serial number I have or basically you can just say I want to write in the position of write I. I was what that stuff was called. So if you write I just want to add this one as an extension to my table. I can't be drawing table. So I's are for 1, 2, 3, 4. Wow. So that means I have to extend this table one more. This table is not enough. I don't want to be drawing another table because I have 5 of those things according to the instructions. Look at the instructions again. I's are 1, 2, 3, 4, 5. The serial number I from 1 to 5. Maybe I should draw a new table because of time. Okay, fine. We have, let's just do it up here. I think it's normal now, thank God. So fine. That way, then we have I. Just write I. So I's are 1, 1, 2, 3, 4. Now to present a good table, this table is just a management table. So this is my serial numbers, which is I from 1 to 5. So the next thing I'm going to do is what? According to the instruction, I'm actually following the instructions. So I'm to record xi and ti. Now xi, as you can see, is the distance. And the distance here are said to be measured in meter. You and I know distance is going to be in meter. But if I look at the meter rule I'm going to use, definitely it's going to be in centimeter. And you can see a very good example is this. So because I'm trying to look for where it was stated, maybe it was in meter or centimeter. Basically, it's definitely going to be in what? In centimeter because I'm going to use a meter rule, which is your ruler. So guys, note that, very important to note that. So I'm going to write xi, which is in centimeter. You can see I'm putting that. And the next thing is ti, which is in time is in seconds. So not in hour. So that's been that. Then I go back here. I want to place my meter rule. Another instruction I would have loved to add if this question is giving you a scale. Let's take for example, there's a scale of 1 centimeter to represent 10 units. For example now, represent 10 units. So what it means is that when you place your meter rule, that is your ruler here, you must have it at the back of your mind that whatever values you are getting, you are going to multiply by the 10 units. But according to this question and according to the examiner here, the examiner did not ask you to represent or to multiply any scale. So there is no scale on this example. So now in continuation, I'm going to look for a ruler here, then I'm going to place that ruler. It says this is my ruler, kind of too long. Yes, it's kind of too long, but that does not stop me from what I want to do because I know it is long, longer than what I actually expected. I have to just move this ruler. Ruler, please come. Thank you. So this is the ruler. You can see the graduation of my ruler is in centimeter. All I'm going to do here is just to flip it and make sure it's going to, I think it's still too long for me because this length I'm having is kind of, no, you cannot adjust your own ruler. I know you guys know that very well. So because you can't adjust your own ruler does not mean you cannot actually, you can turn your ruler to maximize or to satisfy the scale of this that you are given. So make sure you actually set it well. So I'm placing my 0 unit, as you can see, right here. So examiner will not give you grace. That is what that is. Let me say the error grace you can have will not be more than 0.1 centimeter. So that means you have to be careful about the position of your ruler. So my zero scale is exactly, you can see, I will point it for you here at this line. So I'll be able to take x1 to x1. So now again, if you watch something here, guys, I have actually have done some kind of stuff. So which you don't need to. Some of you will be like, wow, why didn't I place my ruler like this? It is measured from what? From this point P up there to G. So if I'm taking my measurement, I should start from P. I will follow the position of the ruler. You can see distance from here to here. So if I have positioned my stuff here, that means maybe I'm actually what doing the wrong thing. So what I'm trying to let you know is that I am measuring in this manner. So I will take my scale according to what I have here. So I'm measuring the distance from, look at the instruction. The meter rule is slightly displayed so that blah 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 blah. So the distance P is suspended from rigid, and the distance X is between G and P. So distance between G and P. So I'm taking from G to P, and that is exactly what we have here. Please apologies for some kind of stuff. If my voice is not that loud, just I hope you can still hear that. So G to P is just what I want. That is why my G here is positioned at this point of the room. So let's start taking each of them. I believe you can see. Now look at X1. I'm using my ruler, or X5 or whatever. X1 to X1. Look at the first X1. At X1 here, this is 6. Everybody should be able to see this. So this is 7. So X1 is 1, 2, 3. So if it's 7, or you can say this is 6.5 here. This is 6.6. This is 6.7. So now it lies between 6.7 and 6.8. So I can easily write 6.75. 6.75 is what I'm going to write for first one. 6 points. I'm using two decimal place. And why? You can see I have actually I have the SI unit in bracket here, so I don't need to put it here. So please keep it in mind that if you are writing anything, it must be at least for one decimal place. That is the instruction. Also make sure everything on your table is what is conforming with each other. What do I mean? I'm actually trying to say you make sure if you are using the two decimal places like me now, everything in here should satisfy your two DP, your two decimal places, two decimal place and slippage. So, we say furthermore, we take all other measurements and we put them. So I will do that very fast so that we can quickly finish up. X2, you can see this is 6 and directly it's at 6.1. There's no scaling effect, so I'm going to put 6.1. To make it two decimal place, I'm going to write 0. So x3 will be the next one. This is 5.5, exactly on 5.5. So I will take that as 5.5. This is 5.50. Then I go to the fourth one, that's x4. X4 from what I have here is also 4 points. This is 4. This is 4.52. So I will also take that as 4.5, not up to 4.6. So I'm going to take this as 4.50. And the last measurement I have here, the last measurement is x5. That is greater than 3.5. It's 3.6, 3.7. This is 4, 3.9, 3.85. So you can see the way I've done my own. So this is 3.85. So the same thing I'm going to record the time. So you are going to definitely have a diagram in your stuff here, which is going to show you what you need to know. Now for this one, to be honest with you guys, I don't actually need a ruler. So I have to just understand the position of the diagram. So when you are doing questions on mechanics, you just have to understand the position of the diagram. So understanding the position of the diagram, I can see that this guy was 30 seconds here. This guy here is 31, and I'm having 32, and here I'm having 33. So I have to understand the gap distance that is between 32 and 33. So in that sequence, I am going to move. So if this is 32, I can say, is this up to 10? 32.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, and 33. So that means it is 1 unit, 0.1 unit. So 32, 32.1. As you can see, the time here is 32.1. So T1 is 32.1. Remember, I'm using two decimal places. I'm going to put 7. So the next thing I'm going to do here is making sure I move on with that same manner. This thing has started lagging again. It's not discussing that. So I definitely going to do the same thing. So T2, no, make sure you don't make mistake. Look at the one that has T2. So 32, if I'm right, this is 31.1, 0.2, 0.3, 0.4, 0.5. So zero point 0.5. So that is 31.50. Lagging yet again. Yes, it is doing that. So 31.50 is what I have for that. That's that about that. So let's see how this is going to pick up. 0.50. I don't know why it is lagging. And I still have to plug that for you guys. So that's that. Then T3, you can see this is 30, this is 30.9. You can see, so you don't need to waste time. I hope you get that now. So 30.90. Wow. The next one is T4. T4. So this is T4. On T4, this is 30.789. This is 7. So 30.7. I hope you can read that now. Very simple. 30.70. That's what we're going to put there. Then we also check this guy, the last but not least, 30.1, 0.2, 0.3, 0.4. So T5 is 30.4. So that's that, 30.4. So you can also always cross-check to see if you don't have any mistake. For instance, this is 32. It should be 32.1. Was that what I have written? 32.1. Yes, you understand. So I think I don't make any mistake. And if there's any mistake, we can always correct that. What I want to teach you is how to do the necessary thing. So I have done the instruction that I read the other time. So in continuation, I am going to move on in that manner. So now measure and record X1 done. Read and record TI, not I1, but I's done. I hope you are following. So we have in each case, fine, evaluate x squared, t, and t squared. That means I'm still going to add 3 other parameters to what I have there. So I'm going to do x squared, I'm going to do t, and I'm going to do t squared x. So let's do that now. So I have x squared, that is this guy squared. So that would be in centimeter also squared. I'm also asked to look for t, capital T. You know, capital T is always small t over n, which is also measured in seconds. So, which is also in seconds. And see, I'm trying to manage space and move your hand here so that you have it, because it's important to put the SI unit down there. Then this guy also say, in addition, I should put t square x. So that means t square, then x. It should be second square, sec square, then centimeter. So SI unit of each of them, as you can see right here. So that means for all these guys, I am going to be needing a calculator so that I can finish up. So let me bring out my magic force and try to bring out my calculator so that we have ease of access to them when it is needed. So I'm waiting for that to pop up. and so that we can fill the table in this video. I don't like it to be too elongated. That is why most time now I just make it short, simple, so that understanding level is going to be what increased, and you are not going to get bored. So I think we have a calculator right here. So calculator, please move to the center, maybe not of gravity. So here we have this right here. So x squared simply means all values here, I'm going to put square them. That is this square. You have your calculator, which is going to be shared at your center. So I'm going to square this guy. Remember, I'm using two decimal places. So I have to be careful with my estimation. So right here, I have 45.56. There is 2 here, so I can just write 45.56, which I believe you should be able to understand. 45.56. Fine. Please, I'm going to be doing this guy once. I don't want to waste time. So T is this T divided by oscillation. Remember, I told you that this is an important information because the period of an oscillation is the time taken to complete a particular number of oscillations. So here in this case, in this experiment, it was 20 oscillations. So we keep that in mind as well. Whatever we have here as our time is going to be divided by 20. So here I have 3210, that's 3310. 3210 here, I'm going to divide that by 20. So what I have here, guys, is 1.605. 20 is coming from the information because I know some students will be asking, where is the 20 coming from? And this guy says you should square this answer, then you multiply it by x again. So times the x value here is 6.25. So I'm doing it directly because I want to be filling the table right away. So here I'm having 17.388. So which I'm working in two decimal place. This does not work with what I'm doing. You can see I have to adjust that. That is very important. So but before I adjust that, this is 17.3. I hope you understand. I'm going to write 17.3. So here I'm going to make some adjustments to 1.61 by approximation method. So I'm doing that. Please, you clean your table well if you're in the exam hall so that you don't actually fall to the trap of the chief examiner. So you can see everything here is in two decimal place. So even if you have made mistakes, that's why most of your teachers or your instructors will tell you that you fill the table first with pencil before you now transfer to Bible. Yes, fine. It's not bad. You understand? So we move, we move, we move. Now you understand the concept now. So we follow the concept all through to fill this table. So I'm going to do that very quickly now. So here we have this guy. We are going to square this guy. So I'm going to put square 6.10. I'm going to square and convert to two decimal place. Right away it in two decimal place. That is 721. I'm going to divide this guy by 20 because there are 20 oscillation. So 31, 31, 150 divided by 20. And this is going to give me 1.575, which is going to be 1.58 on my own estimation. Then here, I'm going to square this guy. I'm using the direct value. Then I'm going to multiply by the initial value of x. That is 6.10. So I'm going to approximate to two decimal places, 15.13. That is what I'm going to do, 15.13. So in sequence, we are going to fill all these. Do I need to fill it? Okay, maybe I will try and plus that. I still have some time here. So let's do the third one. This guy is going to be square, 5.50 square. That is 30.25. Right away, it's two decimal places, 30.25. I'm going to divide this guy by 20. Remember, there are 20 oscillation, 3090 divided by 20, 30.90 divided by 20 is going to give me 1.545. I'm going to approximate to 1.55. Are you there? So 1.55. Then I'm going to what? square this guy here, and I'm going to multiply the answer by the value of x, which is 5.50. So, and I'm going to make sure I don't move more than two decimal places, 13.13, because h was there. So I'm going to write 13.13. So what I said the other time that instructions are going to be followed. The same process are what you're going to use both for electricity or for your light. So just use light or what you call optics. Yes, yes, fine. So make sure you follow this same thing. Experiment is not going to be done. It's going to be kind of a alternative form of practicals whereby you are going to be provided information. We're only testing you on your reading skills and ability to play with the data. Remember to check the scale, which is a question whereby diagram was drawn with scale. You multiply each of the value by your scale. And another thing is plotting the graph, which I think maybe I will do that in a separate video. Yeah, I'm just teaching on how to choose scale and stuff like that. Now, the next one is the fourth one, 4.50. I'm going to square that. That is 20.25. So, and if I've done that, I am going to divide the time here, 30.70, by the number of oxidation, which is 20 oxidation for everything. I'm dividing this guy by 20 oxidation. I'm having 1.54 or 1.54. Why is that? It's just because I am using two decimal places. So the thing says I'm going to square this answer. That's answer squared and multiply by the value of x. The x I'm having here is 4.50. So that is 10.60. If you check the values, they are actually decreasing, whereas this value is also decreasing. So now, the last but not the least, this guy is going to be squared. 3.85 squared. That's 14.82. 14.82. So we have 14.82. Fine. Now, the next one is I'm dividing this guy by the number of oxidation, which is 20. So let's do that. 30.40 divided by 20. Then we are having 1.52. Don't lag, please. 1.52. Fine. So this 1.52, I'm going to square it. I'm pressing the square. I'm going to multiply it by 3.85. So multiply by 3.85. Don't lag. You just stop. 3.85. I'm almost there. Please, 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 please. 3.85. This is our 8.895. So this is where something is for. Those of you who doesn't know approximation, this is going to give you a kind of, let me say, simple headache. Difficult. But if you know what you're doing, you can say 8.89. How will I say that is a 5? Then what will happen? This is where problem is. I know what I'm saying. So now say 8.89. And this is 8.90. You understand? So if you use 8.89, you didn't approximate well, you are going to have 8.90. So that's that about that. So that can be a kind of line that is not going to fall among the line of best fit. But anyway, let's leave that for when we plot that. Now, that is that about the table. This table alone carries what a good mark. So you must not clean, you must not cancel. All those instructions you are given in junior classes are still very much important. So I have compute and construct my table from the instruction of the practical. And this alone is one of those things you really need. Because this is one of the things we are texting you guys on when you are doing alternative to practicals. So don't fall the victim of making mistakes while comporting yourself, while trying to compute your tables. Now, the next instruction is instruction number 4. IV. This says plot a graph of x square, I guess this is x square, not x square n. So x square on, okay, this is on, x squared on the vertical axis and t squared x on the horizontal, starting both axes from the origin 0, 0. So I'm going to make this another important thing. Maybe if time permits, I can quickly teach you today on how to plot the graph. Then I will answer other questions because I'm going to do this last, the plotting of the graph. So other questions here are also from the graph, Roman figure 5. Determine the slope x of the graph. If I don't plot graph, I can't get the slope or the gradient. The next one is evaluate k, which is 4 pi square x. So that means it is when I get the slope, I can know that what pi is 22 over 7 or 3.142 or whatever. Then this is where we are going. I want to give answers to all these guys. I'm talking about Roman figure. This is 7, right? Is it 7? BII should be 7. Fine. Don't mind me. Roman figure 7, 7B1, and so because they are going to test you on your physics skills. That is your knowledge of physics itself. So now, let me quickly give response to this because it's kind of very important. Now, the first one is Roman figure 7. I will do that in the next page. This says you have to state 2 precautions you would take. Look at that construction of the grammar, the position of the grammar. If you are not performing this experiment. So the precautions you would take if you were to perform this experiment in the laboratory. So the language structure, the way you are going to couch your language do matters. So that is what you need to understand. Yeah, everybody do know, yes, I ensure I avoided error due to parallax. I think that is more than normal. You understand? Even there's this popular joke that science students, only God will what? We allow them to make what? We consider them to make heaven. You understand? Because most of you do lie about things. What you did not perform. Say you ensured. You know that language confirmation is kind of not correct. For alternatives to practical. You should have put it in the form of I would ensure. You understand? I would ensure because you are not actually performing it. So that also is being examined. And you are going to what? Marks are going to be deducted. Or basically, you are going to be marked wrong if you are going to put in their language position. So maybe we answer that. Then the B part says explain the time frequency of an oscillation of a system. So maybe we write it down. I'm doing VII. I'll just write that right beside this guy so that you can see. So I'm doing VII. That is the precaution part. So about the precaution part, I will write, I told you it's kind of simple, but it is technical in the sense that the first precaution, which every one of you know, I would ensure my own now. I would ensure tight connections, connections of the meter rule and clamp. Maybe not necessary to write this long. I would ensure tight connection of the pin with the meter rule. I think that is also good. Now, in continuation, number 2, the most popular error that you and I know very well. I would ensure, I would ensure I avoided error due to parallax, parallax when taking when taking my reads. That's the second one. Though you are only asked to mention 2, but it is not only 2. There are a lot of precautions you can take when taking it. You are going to what? Or I am going to make sure I avoided or I would have avoided, this language matters, drought or error due to drought when performing what? If I am performing the experiment. So the examiner only like asks for two. Maybe we shouldn't make it more than two and move on to the next question. So the next question they ask us to, I'm moving to the question, fine, to explain the term frequency of an oscillation of a system. That is B1. So I'm going to do that also by this side. B1. Wow, please don't lag. I'm begging you. Think. Okay, so that means we are defining frequency of oscillation. So you can just write your own way, your own English. Frequency of oscillation. Please write it. Don't be tired. Of oscillation. That is the way examiner has oscillation is defined as the number of circuits. Is it evolution or oscillation again? I just don't want to repeat oscillation two times. So get my point. Numbers of circles, or you say oscillations, you say revolution, anyhow you want to write it, made per seconds. So that's that. You know, it is always inverse of period. So if period is t by n, then f is n by t. So if you want to write formula base, you can say f equals to number of oscillation divided by time. Another person can write. That is why we are examiners, when we check what you have written, we easily know if you copy. For instance, if somebody is writing, everybody in the center is writing this examination, then it makes no sense. Because you can say your own can be frequency is defined as the ratio of the number of ovulation divided by the time of ovulation. Yeah, fine, perfect. It's correct. Cool. You get so you can actually write at your own words, at your own level of understanding, at your own pace. You understand? So that is that about that. I think there is one more before I go to the graphing section. Now, the last one here before the graphing section, let's raise this guy a little bit up there. Now, look at the last question. It says that is B Roman figure 2 again. A metal wire of mass 2G, 2 grams, and length 50 centimeter is placed under a tension. Why would they place the mass on tension? They want to kill the mass. It's placed under a tension of 100 Newton. The question is to calculate the fundamental. So this is a kind of experiment, a question on your testing of what we call a kind of sound wave and the ability of what we call the resonant tube experiment. So this is testing your understanding of physics topic. So if you have the knowledge of the physics topic of sound wave and the resonant tube experiment, especially the sonometer wire, the melody experiment, I am not going into that. I'm only stating that. So don't be what? Don't run away. BC WAEC question on its own are basically formula based. You understand? So they are kind of very easy and very direct words to get formulas and solve. So this is a simple question which you can solve. So for B Roman figure 2, maybe I should change the ink for the first time today. So we have B Roman figure 2. Fine. I'm calculating fundamental frequency. We write that most of your textbook, PN, Professor PN, OKK, and Yakwa, and the stuff you guys use in high school is writing fundamental frequency as F naught. And it is given according to sonometer wire experiment as 1 over twice the length under the root of tension over. Most of your textbook write tension over mass. But I am sorry, it is always tension over. I write my own as mu. Most of these are common on this page if you want to read concept. But for this, I don't think it is kind of needed, to be honest. So it is not tension over mass. This mass, in fact, some of you write it as rho. Yes, rho is correct. Mu here means mu is written as it's called mass per unit length. So don't make mistake when you are doing your calculations. I hope students are there. So the only thing here now, like I said, is fundamental frequency. Question on GC are formula based. So directly, I have the mass. Mass is 2 grams. The only thing is, and this time around, I have to convert. I have to just put a parameter and substitute. Mass is 2 grams. You divide by 1,000. So to get your what kilogram. So I think 2 times 10 raised to 3, 0.002 kg. So that is very important. The tension will be given. I think the mass was placed under tension. They want to kill the mass. The tension was kind of high, 100 Newton tension. That means a load was added of 100 Newton. So note that. Then the mu is mass per unit length. The mass is the 0.02 divided by the length we also did. So the length in this question was 50 centimeters, which I also convert to meter. 50 centimeter to meter will be divided by 100, 1 by 2, 1 over 2, that is 0. So I'm dividing this guy by 0. To avoid error, this time not to parallel, calculation error. I'm going to bring out the calculator again for me to be able to press. The truth is I can do this one without calculator. I just like to show things so that people will not be, wow, this, no. See that you can actually, because you are allowed to use the calculator, you can be very sure of your answer. Divided by 0 to get the mass value. You can see 0.04. So that's that. 0.04. Let me hang this there. So this guy is 0.0. So to finish up this, I'm going to substitute. So directly now to this side, 1 divided by 2 times of the length, which is 4.5. Square 0.5 by that's 1 over 1. So square root of, when I say under root, I mean something is under this big square root. The tension here is 100, my dear student. The mu here we've done that is 0.0. So now I'll focus on what is inside the square root. So and if I do that, I have 100 divided by 0.0, 2,500. Remember that here is the square root. That is 50. So what I have here, I will use a red to write the answer is that. Final answer, I'm managing this guy, spade, is equals to 1 over 1 is to 1. So this guy times this guy is 1. Let me show you. Then multiply by everything here after I've taken the square root was 50. So my final answer to this guy, frequency is 50, and it will be in what? HZ, which you call it. So I have answered all the questions that is provided in this article alternative to GC, whatever you call it. But I am yet to plot a graph to determine the slope and to evaluate K. So I have these 3 guys left, which we are going to do right away. So that we're not just going to do it in one day. So yes, let's do it right away. And we are plotting a graph, don't forget, of x squared on vertical axis and t squared x on the horizontal axis. So that will now make me to explain something. So I'm plotting this guy against this guy. So now I'm going to look at the values of those 2 guys to evaluate the kind of scale I'm going to use. Now, if I watch very well, if you guys watch with me very well, you are going to see that the value here is going down, starting from 45, and it's very easy for me on my graph that is going to be provided by the invigilator or the exam body. It's going to be, you can easily read through decimal place. That's why I love 2D place. And if your values are 0.0000 something, yes, it's always good also to convert to standard form. If the 0.000 is kind of too tiny, that is another thing, but I don't think you are going to have that. I can tell you that. So note, for example, if you have 0.0003, instead of you using 0.0003, convert to standard form and just make sure you use what? You use the whole number that is so convenient for you on your graph scale. So be that as it may, it is now going to be easy for me to plot these guys and to choose a scale that is comfortable. What do I mean by that? This guy is on the vertical axis. Vertical is the straight line that is coming like this, and the other one horizontal is this guy like this. So the lowest number is 14, the highest number is 45. So maybe I will not start from that. Maybe I will use a scale of 10, 10, or 5, 10, 15, 20, 25, 30, 35, 40, 45, provided the lines on your graph goes with that. So I can decide to use 1 centimeter represent 5 units because the scale is kind of convenient and comfortable for me on this vertical axis. Whereas on the other hand, I can look into this, okay, fine. These guys are kind of very close to each other. That is on the horizontal axis. If I try to use 5 or whatever, the highest number here is approximately 17, and the lowest number is what? Approximately maybe 8 or 9. 9 to 18 is kind of very close. So I should choose a scale that is kind of, for instance, kind of not too not too close to each other. I want it to spread out, like it will be convenient for me to plot graph and to estimate any kind of look for my line of best fit after plotting a graph and look for any other things that the examiner asks me to look for. So what I'm saying in a nutshell, it's that using a scale of 5, 10, 15 will be kind of too close. I can decide to use a scale of 4. You understand? Once maybe 4, 8, 12, maybe not. But in this case, I prefer using a scale of 2. Yes, like 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So I think I have actually gotten my scale from prediction. This guy, I'm going to use 1 centimeter that represents 5 units. And on the other hand, this guy, I'm going to use 1 centimeter to represent 2 units. So that is that. And if you think the spacing is kind of not, you can change it to 2 centimeter as leaving a gap in between one to move to the other one. So that is that about that. Let's try to do that by visualizing. I will try as much as possible to make this thing more kind of realistic in the sense that you are going to be needing to see something of such. I just pray it's going to work. So I need to add one more page. One more page. Thank you very much. And with respect to that, let's put in here. Then the magic box, please give me a graph, a line graph. Please, you have to know how to plot a graph. A line graph display. Excuse me. Okay, fine. I have one. So this is a line graph. This is a full line graph that is having both negative and positive axis. I don't actually need that. So because of that, I may decide to actually let me center this and increase this guy. Let me increase it here. I don't need this one here, guys. This I can cancel. I only need the positive and the, you guys know what I mean. Yes. So now the problem here is the scale here has been given. And I don't want, those are the problems I'm going to have. I don't want to be ruling and be showing anything. I want a scale. So you choose your scale. All scales here are 1 centimeter, which I wouldn't love. I would have loved to see a line graph that would show me exactly the point I want you guys to see. That is talking about graph that has different points. This graph is in 1 centimeter. Can't I choose a scale? Just thinking there should be a way. Oh, not you. Okay, fine. So if I'm choosing the scale now, I can choose a scale. I should be able to write there. The problem is the interval of what in your own graph, you guys definitely going to have something a little bit different from this in the sense that you guys should just understand what I'm trying to say. In between your own line, there's a dotted line, there are like kind of 10 columns. They're like 1, 2, 3, 4, 5. Understand? So you should be able to count that very well, please. Because that is very important in graphing. Some of you don't know how to do that. I need to let you know. So I don't know why it is. I should be able to put my own stuff. It's not gonna make sense here. So fine, but it is not the end of the world. I'm only focusing on this. Let me see if this is going to work for what I will explain. Remember the scale I want to choose. You have to label your graph. I'm plotting a graph of x squared. Look at this. So I have to label a graph. Please just listen to instruction. X squared on the vertical axis. So let's use red. X squared. I'm writing this one is helping me to bring. I'll ask you to write. I don't know why it's not writing. This is not writing. This is right. Okay, it can only write here. Anything outside, okay, x squared. Wow. So let me just follow the way it should be written here on your own. Or basically, I might disturbing myself. I can just write up there. Let me position this for you guys. Come over here. Time is not on my side. That is why I'm plotting this guy last. Okay, fine. So now I have to label a graph, no matter how. So this is a graph of, I just write graph of x square in centimeter square against, you can see I'm labeling against, is it t square x, t square x, t square x in centimeter square seconds. So that's my graph. So here I'm writing x square in centimeter square, and down here I have to reduce this so that we have space. Do I even need the one under? I don't think I need that. I only need a straight line graph that. Yes, 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 yes. Wow. I should have actually go for my own graph, but I won't be able to have a scale. That's what I'm looking at. Because the graph is kind of the very problem, to be honest. Okay. Having issue, okay, fine. I should be able to. Because I know what I actually needed, to be honest. This is what I needed. I really need this one down there. I need this one I'm being given. I only need something. I only need this y and x axis to plot the graph. So I'm going to manage. Just take it the way it is now. So now that is x squared, and here remember is t squared, t squared x. Sorry, the graph is kind of not t squared x, t squared x, t squared, t squared x in centimeters squared. So that's that. Time is not. I have only 9 minutes more to finish up this. Then it will be an hour video. So now here, let's check it out. The values are there in the previous table. I've chosen the scale, so I have to write scale too. I want to write scale, scale on x axis, scale on y axis. So I'm going to write that here, scale on x axis. X axis is this kind, and here I'm using 1 centimeter to represent 2 units. I hope this will be sufficient. I also have scale. You can write that one at this side of your graph. Scale on y-axis is 1 centimeter to represent 5 units. So that's my scale. So now, like I said, there are going to be some gap in between, and those boxes are going to be 9. So you must be careful on how to count them. And if you still have difficulty in this, you can just drop a comment. I can still look for next class. I'll just find a graph, the exact graph of yours, and place it here so that I'll be able to show you all things you need to see. So now it's now left for me to just fill in my stuff. I use 1 centimeter as unit. So that means if this is 0, 0 point, this guy is going to be, I think now I need to write the stuff. This guy is going to be 2. So 4, 5, 6, 8 is kind of too close. 10, 12, 14, 16. But if I have this kind of no, the normal, I'll use 1 centimeter represents 1 because it will be kind of simple for me to plot. That is what I will use, to be honest. Because I wouldn't want to use something that is too close because of the nature of my graph. I can just use 1 centimeter represents 1 unit here because my graph permits me to use that. So now I will just adjust that. So I have 1, I think 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. I can tell you your own graph cannot allow this. So it's whether you use 2, maybe 2 centimeter, 2, leave a gap, 4, leave a gap, 6, leave a gap. So 2 centimeter by 2 units will be sufficient for your own graph. Then on the other hand, look at this guy. Let me just use 2 centimeter represent 5 units. So that we have something that makes sense. So that means I'm leaving a space, I have 5. Then this guy, I'm going to leave a space, I have 10. I'm going to leave a space, I have 15. I'm going to leave a space, I have 20. I'm going to leave a space, I have 25, so that they will not be two together. So let me just use this as my own explanation stuff for you. So that's that. Then the next thing is I'm going to look for the graph position, and I'm going to look for the line of best fit. So this is just a sample of what you are expected to do. Choosing a scale is very important, and placing and understanding how to get to plot your graph. So let's just plot some, because I want to end this video. When this guy is, I'm plotting a graph of 45.56 against 70. So when y is 45.56, now look at what we're talking about. Oh, that means I cannot even use this guy because I'm having 45. So let me just use it as 1 centimeter to represent 5 units, not 2 centimeters. So here now, what I have, because I have 45, 5, this right, this 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. So that's just that. So let me just show you how to plot and call this a day 45.56 against 17.39. So here 45.56. This is 45. Then the gap will be 46, 47. So you count 1 to 46, 1 to 47, 1 to 48, 1 to 49, 1 to 50. So there are 10 gaps on your own graph, on your own booklet that the examiner is going to provide. So if you are using this scale, so that means when you count 1, 2, that is 40, 46, 1, 2, 47, 1, 2, 48. That is the way you are going to move. So now 40. What am I looking for? 45.56 will be 45.5. 45 before I get to 46. 45.56 will be around here. Then I'm plotting that against this particular value against 17.39. So 17.39 is what I need here. This is 17. This is 18. So 17, 1 to 17.1. 17.2, 17.39. So around this place, which you are going to trace up there, I hope you get that. Then to 45 point, this is 45. You can see this is 45, this is your 17.39. This 45 point, it's above 45 a little bit, something around there. Some of you like to use star, you use cross, anything you are using. I just like to use point like that. So that's that. About it. That's the first line. So I will continue in that manner to plot the rest. Let's do that very quickly. I hope you get that. So you start tracing. The next one is 37, 21, 15, 13. 37, 21, 15, 13. 15, 13, 15.1. 15.1. Then 35 is 15.1. Then 37, 21, 35. 1, 2, 36, 1, 2, 37. So here you can see this is the line. So that's that. So some people like using something like this. It's not bad. Something like that. So you continue in that manner. The next one is going to be the third graph. 30.25, 13, 13. 13, 13, 30, 25, 13, 0.121.13. So around this place, 13, 13, and what is that long guy? 30, 25. So 30, 25, 13, 13 is 13, 13. This is 30, 30.1, 121.125 here. So this point is that graph. So that's that. You plot the last two. Maybe I leave that to you. Just want to show you 20, 25, 10, 60. 10, 60, 20, 25. This 10. 10, 60 will be after 10 points. 1, 2, 1, 1, 2, 2, 1, 2, 3, 1, 2, 5. And this is 10, 60, 20, 25. This is 20, 25, 21, 22, 5. There, that's that. So then the next one, the last one only, 1482, 890. 1482, 890. This is 8. 890 is very close to 9. 1482 is 15. 1482 will be very close to, you see, there, very close to 15. There, 890, 1482. So this guy, I'm not this again. So that's that. Maybe not straight enough, but definitely you are going to get. The next thing when you have plotted this one is to look for your line of best fit. So the line of best fit is always where most students do have issues, but most of them don't know how to get there. So looking for line of best fit. Now let's do that together. That is the line, at least 3 lines, 2 lines that will fit what you have drawn. You get, because you have to get that too. It's very important. So let's get that. So like I said, let me reduce this rule so that I'll be able to get my line. It's even too thick. The ruler is too thick. So I'm going to place the ruler in such a way that reduce it against the true. Okay. So what I'm seeing from here, my diagram was not drawn to scale. You place your ruler such that you are going to get your own line of what you think should be the line of, I think these three. Basically, I'm having those 2 lines here. According to what these two is mating. Looking at, I think these two only is mating. This and this is not. So I'm having this and this. So this is where I'm going to draw my line. It's my line of best fit. So I'm going to have, let me use the black. So if I say I want to go for this, doesn't work. These two do work too, but it does not work. So I prefer coming to the center of the line, right here. So then I'm going to draw it. So this is the line. According to what I have here, that's my graph that I used. That's my line graph. So that is the graph that we have there. Let me just place this guy on that side what I'm explaining. So that is my graph. Then the next question you have in the first slide says, time is not on my side again. You have to find the slope of the graph, the slope S, then evaluate 4 pi square x. So the slope is always the rise over the run. So which is basically what I believe you all have studied in your junior classes. Let's do that with a blue. So the slope, I just do that inside there, is the rise over the run. The rise is changing y, data y, over changing x. So basically you say y2 minus y1 over just manage that x2 minus x2. So you just place value. So to your own convenience, you can just draw the right angle triangle the way your teacher will always would have explained that. So just draw. I always love to use the point I use for my graph so that it will be kind of easy. I know this point if I trace it down. So I know this value. So I'll just draw a short triangle like this. Sorry, I have to just do that. So then I'll be able to get my estimate. For example, I know the value of this. I think this was the one, two, three, four. This was the fourth value here. So the fourth value, one, two, three, four. So I know on the x-axis is this, and the y-axis is 2025. So what else will I do? So I'll just count these guys. This value is 2025 or whatever. The fourth value here, I can easily trace this guy. So one, two, okay, it was the one to the second value, not the fourth. So you can trace it as well because I have the point 37, 21, and 15, 13. So that's that. 37, 21, 15, 13. So this is it. This is 37, 21. My y2 is 37, 21 minus the lower value is the third value. So you can see what I'm talking about. That is 30, 25. So I don't need to be tracing anything because I have the values. 30.25. I am dividing everything here by this guy. I know this guy for 37.21. I know the x answer for that. For 37.21, I have 15.13. So I have 15.13. You can see minus the lower value of the third one. I know the value too as well. The third value here, that is a 13.13. So you can say 13.13. And this is 13.13. So the rest is just story. I'm going to point that calculator. Maybe I should bring it again. The magic balls, the compass, and here comes the calculator. So we finish up with this one. Oh, waiting for that guy to come up. The guy is still loading. The guy will soon. Yeah, here it comes. So here directly we can now say fine. So let's just do some kind of subtraction to get this slope. 37.21 minus 30.25 is giving me 6.96. So 6.96 divided by this guy minus this guy should be 2. 2.002. You just write 2 anyhow. So divide this answer by 2. If you are not sure it's 2, you just subtract yourself. That's 3.48. Now, the question is, if you have written 3.48 for the examiner, you are correct, no doubt about it. But the problem about this is that you have to put the XI unit. What and what are you plotting against each other? The Y. What is the SI unit of the Y? Centimeter square. And the centimeter square, watch this. I'm going to write the SI unit by the side. My answer was 3 point, because I can't write outside the plane. 3.48. I just want to show you how we get answers. Centimeter square over, you can see that is over a slash. Look at this guy. Centimeter square. Can you see? Then seconds. Now, what do you know in your mathematics class? What happens? Centimeter square gets cancelled out. So you have 3.48. That is our per centimeter square. That is slash, that's 1 over centimeter. Now per second. That is seconds raised to power of -1. So if you don't write it like this, my dear student, I'm sorry, 0 point, I said 0.1, 1 mark is going to be subtracted from your answer. So that is why you need to do everything right. So do it right so that you don't have any issue. So in that manner, I have answered all the question, I guess, only this one. After getting the slope, evaluate k equals to 4 pi squared. I think that's the last one now. So evaluating k equals to 4 pi squared. I'm going to do that here. So the next one, k is equals to 4 pi squared x. Don't mind my handwriting on this guy. It should be 4 times, pi is 3.14. It should be given though you square it times the answer of your slope, right? What is your slope? 3.48. So the rest is just history. 3.14 squared times 4 times 3.48. Now, I have to also let you know something. You also need to put SI unit here too. You can say pi doesn't have unit, it's a constant, so you still put the per seconds here. So this is 137, wow, 137.5 25 approximately. I've been working with two decimal place, remember, also. So please, again, if the question require you to put it in a particular significant figure or whatever, you have to follow it. So now, dear students, I have answered all the questions on this, including the one that is more of your, excuse me, more of your questions on your knowledge of physics. And that is exactly the same pattern. You can see my table very neat. I did not cancel anything. All questions are answered the way it should be. And precautions I told you about, the language, the way you are going to position your language is very important. Your graph scale, I told you about how it's going to be what given. Make sure at least two is going to touch, and make sure you understand the best line. And see, it was because I used the best line, it was very easy for me to calculate my score. And that is why it is so easy like this. So, a lot of questions about should I plot with biro? You cannot plot with biro. Definitely, you have to plot with pencil and do your calculations with biro. So, if you still have more questions about what you still want to know, you can drop a comment on the section. I'll be glad to attend to you. So this is the end of this section. I wish you guys good luck. Take care of yourself. Thank you for your time as well. And if you're a newcomer, consider subscribing to this channel. Bye for now. Thank you.